In today's note, we're going to be combining the last two lessons into a real-world application. In the last two lessons, we looked at finding the measure of angles and finding the length of a side using right angle trig. We're going to combine that to find the height of really tall things. And this goes back to what we looked at in on the first day of that very large tree. So if we want to figure out how tall that tree is, whether we use that to extrapolate and figure out how old it is, or just for curiosity's sake, or even if we're trying to find the height of anything or build the height of anything, we can use trig to figure that out. So what we're going to do, have our person here, and he's trying to measure the height of this really tall thing, which we're just going to call something tall. And the key information that we're going to need is first the height of the person. You need to know his, because what we're going to do, and we can see the triangle already kind of figured out here, we're going to need to use their eye level to help us find an angle. And that angle is going to be here. The way we figure out that angle, one, we can use a tool called a clinometer. There are more digital options now, but basically what it does is it measures the angle from when we're first staring on a horizontal, or basically standing still and staring straight across, and we start to tilt our head up till we see where our eye level is at the top of the object. And that angle that we form between those two spots, staring straight across and then staring up at the tall object, that creates our angle, our triangle. That angle has a specific term. It is called elevation. So that's our specific angle, or a specific term, and that's basically, again, formed from looking straight across and then going up. That is our elevation. Other thing we're going to need to know is basically this value here, and this is the part of the triangle. It's not the entire height of the object, which we'll get to later, but it's basically from where our horizontal or our eye level is to the top. And then finally, we can figure out the bottom side, which is the distance from the object. And it's a lot easier to figure out the horizontal distance compared to the vertical distance. You can measure how far we walk away from something, or we walk up something. So these are the pieces of information that we're going to need to help us figure out this height of this tall object. We can already see the triangle here. Again, we're going to assume that it's a right angle here, that you're standing on the same level, you're not above it or below it, would create a non-right angle triangle. But if you're on the same level, or roughly, that it is a right angle. So based on the information that we have our angle here. If we were to label the sides of this triangle, we would have our opposite and our adjacent. And if you remember the formula or the ratio that deals with opposite and adjacent, tan. We have tan theta equal to our opposite over adjacent. That's our formula. And in this case, we're going to still call it tan theta. Our angle is still the same. But based on our image, we're going to look or need to know x, part of the height, plus or over d, which is the distance from the object. Key things you want to know from this. Again, what you're going to do first, you're going to solve x. You're going to need to solve for x, and in the past we have examples of how to solve for x. All the other given information. Let me just put his little note, theta, and our distance from the object would be unlikely that we would not have those two, because those are easy. So first step is we're going to solve for x, and then the second step is that we have to add the height of the person to x for our total height of the object. Because again, we have the height of the person here, which is this lower part called h, plus the height from the eye level to the top of the object, which we found using trig, and that combined would give us the height of the object. X plus h equal the total. And that's how you can use trig to figure out the height of the object, height of an object. You can do this from, say, trees in your backyard to your house. The only thing is that you want to make sure that you have the correct distance from the object and the correct angle of elevation. If you think about how far up your head can tilt, as long as you're not staring straight up at it, which would form another 90-degree angle, which would not be able to create a triangle, you can find the height of any tall object. And then, of course, as long as you can find the angle using a clinometer or some other. But again, that's how you can trig in a real-world application to figure out heights, and you can see this in construction or large designs or projects, like roads or building anything, ramps or grading hills.